Okay, so the carbon footprints are getting bigger and bigger here. We are moving to 1 ton to 10 ton CO2 equivalent, and we start with the heart bypass operation. Not something necessarily you would think of when you are having a bypass operation. I mean, carbon footprint would not probably be on your mind, but it should be on your mind before you get there, because all the healthy habits like riding a bicycle, eating less meat, protein from vegetables, and so on are likely to reduce the chance of need for a heart bypass operation, right? But the CO2 equivalent, if you were to be cold-hearted about the bypass operation and just tell you what the carbon footprint of your heart operation is going to be. You see how I did the cold-hearted and the heart operation? 1.1 tons of CO2 equivalent. That's nearly 6 weeks of a 10-ton lifestyle, equivalent to a couple of return flights from San Francisco to Vancouver. The cost, the carbon footprint included here accounts for all the paperwork, the insurance companies, the hospitalization, power consumption at the hospital, how clean they have to keep it, the equipment, doctors, and so on and so forth. So obviously it's never going to be complete, but the point is that if you needed a motivation to stay healthy, and if you are somebody who worries a lot about carbon and climate change, then you have another pathway to stay healthy and reduce your carbon footprint. Okay? All right. The other thing that shows up here is photovoltaic panels. This is also quite a complicated story in terms of its potential for reducing carbon footprint, climate change, being part of the global warming targets of 2 degrees centigrade with a 66% probability by 2100, and so on and so forth. But there are actually carbon footprint issues as well, and we will see there are other financial and waste issues that need to be looked at as well. So 3.5 tons of CO2 equivalent for producing a solar roof capable of generating 1800 units or kilowatts hours of electricity per year, 1800 kilowatt hours of electricity per year. 50 tons CO2 equivalent lifetime savings, that's 5 years worth of 10 ton living, 5 years worth of 10 ton living. Okay. Warning, this section contains myth-busting payback calculations that will interest some more than others. Basically, the author looks at the subsidy process in the UK for installing rooftop solar, the cost you have to bear in the beginning, and the return you will have, including the subsidies, the power and the subsidies. And the argument is that the subsidies or the paybacks from the government right now are not well thought out in terms of how much it costs and what a person could earn by using that money to do other things than to invest in solar panels. But then there is a discount rate used for future earnings and future losses of your investment, which is used as 10%. And the author argues that's typical, but depending on who you ask, that's quite a high discount rate. Basically, that means if somebody wants to give you $90 today, it'd be worth $100 next year, would be worth $90 today. So you are better off taking $90 today than to wait for a year to get $100 if there is a discount rate of 10%. Things like this, right? So how quickly things devalue in the future is always critical. And there are other issues. This is from IEA, International Energy Agency, making its projections. So the World Energy Outlook has revised its projections constantly based on what was actually happening. So this is in gigawatts, a solar global forecast of cumulative installed capacity. So this is only to 2017, and I think we have shot past that, so this is an older report. And wind global forecast of cumulative installed capacity also has been revised based on the actuality. So the cost and the installed capacities for wind and solar are going up. This is of course seen as a good thing, but in places like the US, where you get a subsidy and you get to put the excess energy you produce back onto the grid, is beginning to raise flags with the power companies, which actually are privately held. They are for-profit companies, so if people start collecting subsidies, producing energy and putting it back on their grid, it begins to affect the energy market and their profitability. So they are beginning to not like this so much. So here is an article from America's Power, and you can see the caption: "It's time to end subsidies for renewable energy." Tax subsidies for renewable energy in 2019 billions has gone from 10.9 for this period. It was somehow lower, 9.6 in 2000 to 2009, 82.1, and then the total over this period has been $103 billion in total subsidies for renewables. So depending on your capitalistic motives and how your company wants to make money, this can begin to chew into your profits and so on. So this is the estimated initial cost of new renewables in 2110 dollars, so 100% in 2010 for onshore wind and solar PV. Offshore is not included here. So the costs have dropped continuously over time from 2010 to 2020, and they are expected to continue to drop. This is used as an argument to say that renewable companies do not need subsidies anymore. Okay, but the agency involved in arguing this is called America's Power, which obviously is got its own motives, which may not necessarily be about reducing emissions and global warming. Okay, the Harvard Business Review says the dark side of solar power is the solar trash wave. Is this also motivated by the energy industry's interests? Not very easy to know that, is it? According to our research, cumulative waste projections will rise far sooner and more sharply than most analysts expect, as the below graph shows. We'll see in the next slide. The green no failure line tracks the disposal of panels, assuming that no faults occur over the 30-year life cycle. The blue line shows the official International Renewable Energy Agency forecast, which allows for some replacements earlier in the life cycle, and the red line represents waste projections predicted by our model. So here is the gigawatt scale in cumulative capacities, and going from 2020 into the future 2050, projections are being made by IRENA. So various assumptions go into these, as we saw. If you assume no failure in the solar panels, then you have a different trajectory, but early replacement of failed solar panels is going to produce much higher cumulative capacity. So this is the trash wave. The higher the gigawatts you are aiming for, higher the trash wave is going to be. So obviously it's a legitimate argument that when you do the life cycle analysis, you have to worry about the cost of getting rid of or recycling the solar panels, right? It's some kind of circular economy has to be devised for solar panels, subsidies, recycling, etc. But again, what are the motivations behind them? It's not always clear. Nonetheless, fossil fuel companies are fighting strongly against renewable wave, but they don't talk about the fact that, at least in the US and many other countries, they are getting fossil fuel subsidies. I mean, they are getting subsidies for a long time. Costs of energy related tax preferences by type of fuel or technology, looking at 1985 to 2015. In 2015, $billion. You can see that fossil fuels, renewable energy, and nuclear energy. So there is also energy efficiency subsidies provided through various mechanisms, like Energy Star products. Fossil fuels have enjoyed subsidies for a long time, but now obviously the newer subsidies that have started more recently for renewables are much larger. So how do you account for the disparities between fossil fuel, which has collected subsidies for a long time, versus the renewables that are just coming into the market? And how do you put the cost on reducing carbon, air quality, cleaner water and health impacts, and of course related things on crop yields and just quality of life and so on and so forth. Okay, so these are complicated arguments, but if we want to just be cold-hearted again and just look at solar panels, then they do have a carbon footprint of 3.5 ton CO2 equivalent for producing 1800 kilowatts of electricity per year, but they have 50 ton CO2 equivalent lifetime savings, which is 5 years worth of 10 ton lifestyle that you can map for yourself. So obviously there are lots of issues in each item, and when you and if you wish to install solar panels on rooftop or elsewhere, you have to do these calculations. And if you are somehow very enthusiastic about doing your bit for climate change and reducing carbon emissions overall, then you may go for solar power, but you still have to worry about the waste after its life cycle is done. So you don't get a free ride just by saying I'm doing something good. You still have to worry about life